Welcome everybody, and welcome to the ones who may be following the stream too. We are very, very happy to have you here. And this is the premiere of the concept MusicLab, which is a collaboration between Ritmo and Realfagsbiblioteket. And it's actually mainly Realfagsbiblioteket inviting Alexander and his people to his own project. Okay, so we want to mix open science with open bar, a lot of music, a lot of technology, a lot of fun, and we want everybody here to experience a lot of things for free and at the same time just serve science just by being here. And I especially welcome a set of 10 guinea pigs who are our heroes today. So welcome to you.
Should we explain that a little bit too?
Yeah.
So the idea now with this is that and the reason we call it MusicLab is because one thing is that we want this to be an outreach activity. So we're going to talk. We have an intellectual warm-up first with a panel that we'll introduce very, very soon. Then we have music performances. And during the music performances, we will actually capture data from 10 of you sitting around here. So we will capture muscle information during a muscle performance. And these data will then be used right after this in what we call DJing. This is a new concept, data jockeying, where we will actually be able to look at the data while they are being massaged and programmed right afterwards. And you also you can get the data yourself and also participate in this data jockeying yourself while drinking beer. So that's kind of the story. So welcome to the first edition of MusicLab, and let's get started. So I'm switching a new hat now as moderator of this panel. And today's topic is what we call biophysical music. And we'll have this intellectual warm-up to kind of try to figure out what this concept means and how we can think of really biophysical and music in the same way. So we have invited some experts here today that will shed light on this. We have, first of all, Are Brian, a neurologist, sitting here. We have Marco Donnarumma, performer, and he's going to perform later as well with his muscle microphones. Karianne Bjerkestrand, dancer, choreographer, and Jo Brusgaard, biologist. So we have kind of covering this from different perspectives. And I asked all of them to kind of say a few words about who they are, the background, and why they think this is interesting as kind of as a start. And we thought that we should start out kind of looking at the whole body broadly. So I asked Karianne to start out by saying a few words.
Yes, I'm a lover of movement. When I was 8, I started dancing, and I can remember the first class of ballet. I got totally it was like magic to me. I can remember my body, those first minutes of the class. I remembered how I organized my body in copy to the teacher. I remember this experience very, very well. And since then, I was completely in love with movements. And I had only one thing in mind. It was becoming a dancer. And I became a dancer. But actually, I think why I started to dance was a reaction to my parents forcing me to play the piano. My parents are musicians, and I grew up kind of underneath the grand piano in our living room. And one day, my mom said, I think you should start playing the piano. And it didn't work, because when I was rehearsing at home, people would yell from the second floor, fourth finger on the, crossed B and so on. So when I started to dance, it was like freedom. I was free from the music, but still the music was very much present in my body. And this has been a major inspiration for me as a dancer, the musical approach to movement. So sometimes I say that I'm actually a musician using my body to play music. Yes, and the love of movement continued because I also began Tai Chi, which is a Chinese martial art, which focuses very much on not only the movement but also stillness. And the last 10 years, I've been actually standing more still than moving in my career. And this led me into the work of Alexander, where we have been standing still for 5 years now, I think. measuring the body, standing still, going into the experiences of really deep stillness, and coming back to where it all starts. Where does a movement actually come from? And from where do we create? Either as a performer, when I'm performing a movement, which processes are there before I actually do the movement? Or when I'm creating a piece or an idea, where does the idea come from? So it's been like a spiraling into nothingness that again opens a new dimension of creativity.
Thank you for the introduction. And then let's move over to Marco, because Marco is not a dancer. You're coming from a music background, but you're moving a lot, but to create sound.
Yeah, so I would call myself a performer, which implies a lot of different things, among which the most important perhaps is the fact that I use my body and body of other people as well as a main means of explorations. Exploration of what? Well, of different things, of sound, of the body itself, the body and sound, but especially the relation between body and technology, which I believe to be always a two-way relation. So I try to explore alternative ways in which technology can affect the body and vice versa, the body can affect technology. And what interests me the most is really what kind of bodies we can have and we can do that are different from what we are used to or forced to imagine in our own societies. In a very large perspective. Then the reason why I'm here is because I perform with a so-called NIME, a new interface for musical expression, and I do this since several years, about six or 7 years, and you will see one of these performances tonight. And in this particular case, I use sounds from my own body as I move as material of composition. So I compose their sounds in real time through this instrument and computers, of course. Where the final goal, though, is always provide a sound experience and possibly something that will communicate something meaningful.
Great. And one of the things that I think is super interesting is really the combination of art and science in different ways. So that's also what we are trying to do here. So now we're moving from the art part into the science part and getting closer to the body, looking at you now as a biologist, because you have also actually been making sound from the body.
Yeah, well, not from my body, but from a mouse's body. I'm a muscle physiologist, not only a biologist, so I've been working on muscle for 15 years. And you talk about communication with the outside world. I mean, muscle physiologists always have this kind of complex, and I mean, people working on the brain, they're very important in the physiology community, but the brain's only way of communicating with the outside world is the muscles. So I always use that as a sort of an excuse for doing muscle research. But when I did sound recordings from the muscles, it was from single cells that I recorded the electrophysiology part of intracellular voltage. And I converted that to sound. So for my laboratory for a couple of months, it was all the time. So that was my little contribution to arts, I guess. No, so I'm very much looking forward to this performance. I have been reading a lot about EMG, the recording of the electrophysiology part of the muscle, but not the mechanical part, which we're going to do today. So I'm really looking forward to that.
Just a follow-up question for you then. Could you explain what's really the difference between EMG and MMG, if you try to kind of wrap it up?
Well, when a muscle contracts, it creates an electric field around the muscle, and that electric field can be picked up by electrodes. So, and that's the same thing you use for your heart when you do heart measurements, and you can do the same on the brain. But when the muscle contracts, you record this electric field, and you get the readout on the screen usually. But of course, that signal could be converted to sound as well. But when it comes to the mechanical recording of a muscle, from what I know, people really don't really know what's going on. There's been some publications on this the last couple of years, but and it correlates with the electrical signal, more or less in an inverted way. But so when you have a high signal on the electrical signal, you have a low on the, and vice versa. But since we don't know really what we are recording actually, other than sound or really movement, that's really what's being measured is movement. So despite the fact that it correlates well with other recordings, it hasn't been much used, I guess, in clinic and in science. But maybe that's about to change.
Cool, thank you very much. And then Are, the neurological perspective on this. What's that?
Well, the neurological aspect is, as with anything, everywhere, of course. I'm a neurologist by training, but I also work as an associate professor at the Norwegian Academy of Music, teaching about music and the brain. So this is kind of in the midst of my core interests. And I think this, for me, is very much about the senses in a way, because when you observe someone and you recognize a feeling in that person, what do you recognize really? It's like you say, the brain's only way of communicating with the rest of the world is through movement. So when you recognize a feeling in someone, you actually recognize the person's movements in the face or in the body. So, and then because of the strange and complex system called the mirror neuron system that we all have, you recognize that automatically, and you pick up the same feeling from within yourself. So movement is a way of communicating feeling through vision, through your eyes. And I think what Marco does and what you do as well is, for me at least, a way of communicating movement, that is muscle movement, through sound, which for the brain basically is the same thing, because sound and music is also a way of communicating feelings. So you're on the same track, but you do the conveying of the feelings through music instead of vision.
You mentioned the concept of mirror neurons. Could you explain what exactly are these mirror neurons?
Mirror neurons are neurons in your brain's cortex that are active when you perform certain movements, and that are also active when you watch someone perform the same movement. So if I move my right arm and you look at me doing that, your brain will be active. The neurons that control your arm will be active. And the point with that is that through that system you can extremely quickly, in a couple of hundreds of a split second, you would know my intentions. And if you watch my face move and I make a happy face, you will recognize that instantly, because that movement maps onto your motor cortex. So it's a way of mirroring automatically someone else's intentions or emotions.
one thing that is very fascinating to me, and that's, I guess, in our research in now in the Ritmo Center of Excellence, body motion is a very important thing, that we look at the body and how it moves with different types of motion capture system, etc. But now, today, we're focusing on the muscles. But then, perhaps a follow-up question here, and this may be mostly to you in this case, is it's really motion and muscles, and particularly also some of the things we have been working on this SWAM project is not to move, but still use the muscles. And what's this connection here between the movement, non-movement, but muscle and tension type of things? Could you explain a little bit more there?
This is obviously a neurology question as well, because I mean, when you do a coordinated movement, if I lift this arm, I use my bicep, but at the same time I have to inhibit the signals that go to the triceps, which do the opposite movement. And that sort of coordination takes place all the time when we do coordinated movements. And doing movement very slowly, for instance, which I know you have been working on, doing it very, very slowly, that demands a very good control over the muscle. Not only moving the muscle cells that actually move the arm, very not a controlled movement, but you have to inhibit all those other cells that would normally participate in the movement. And that is sort of an active process in your brain. So not moving and not doing a contraction of the muscle actually involves a lot of activity in your brain. Or in your neural system is more correct, perhaps. And
Karianne, how does it actually feel then to not move very much like this?
Because standing still is hard work, actually. Because we are created to move. It's natural to move. So to put the brakes on and attempt to stand still over a period of time is very strenuous. And when we had our rehearsals, we were standing still several periods during the day. And I felt when I came home that I'd been skiing for 4 hours. I was completely exhausted from standing still. So it kind of builds a new strength that you have to stand still. And then, of course, it's all these inner experiences of standing still, because when you still the body, you become aware of, for instance, your thoughts in a new way. And when the thoughts become still, then maybe you discover emotions. And when emotions, I mean, this process just goes on, and things are coming more and more to stillness. And in the end, what is there? It's pure presence. And that is a very enjoyable and pleasant state of being.
Since you are in the informatics building right now, where technology is quite important, I'd like to also just move over to technology a little bit, because, and this was mentioned earlier, this difference between the EMG and the MMG. And the interesting thing today is that we're actually going to have performances with both EMG, first in the piece that we are going to perform, Karianne and I and 2 other colleagues sitting here. And then we're going to have the MMG performances with Marco's pieces. So that's going to be an exciting thing to work on here. But technology and working with these things, Marco, what's your experience really kind of trying to embed and use technology to capture these things? And how do you approach it? And what type of tools do you work on? Do you want to kind of open the box just a little bit there?
Yeah, it's always an interesting problem. So yeah, working between art and science is always a funny issue, because most times, at least in my experience, what is valid from a scientific point of view, it's not very useful at an artistic level. So of course there are several areas in which the two overlap. I think the most difficult, the most important thing is to understand which are these areas that overlap and which are necessary to each field. So, for instance, when I was in Goldsmith, we did a lot of research on how to interact with the computers through biosignals, and most of the methods that we developed for everyday interaction with interfaces were not very useful then for the performance that I've been developing. But of course, the knowledge was indeed useful. And so with that kind of knowledge from the scientific field, we were able then to understand, okay, so maybe that piece of data that we discarded the other time, that's actually maybe very useful in this performance, why we don't try to plug that in. I think at some point there is this bifurcation. Even if you work within art and science, methodologies are not the same. So at some points you have to take decisions, but the decisions are not exclusionary, quite the opposite, yeah.
And then the final question from me before we open for some questions from the audience as well, to Ares, is you're also kind of working in between science and art in different ways. So what's your take on this, and the connection really between the art and science, and how can they influence each other?
I think the two share common grounds because both of them are ways of finding out about the world or about the state of being human, really. That's what science is about, trying to find out ways to explore what it is to be a human being in this world, and which basically is what art does as well. So I think the common grounds are there, obviously, and then you can like draw wisdom from one another in different ways. And I think also the concept of creativity is kind of common grounds for both art and science. So there are many things in common indeed.
I'd like to open the floor now to if there are anyone from the audience that want to say something. I don't really see that much myself from here, but anyone?
There are no stupid questions. Okay, yeah, one.
Okay, it's a question for the whole panel. What kind of other sources of sounds and music is it in our bodies?
Do you want to try?
Well, in my research, I've been researching, looking into the pressure regulation systems in the brain, placing detectors within the brains and the spinal fluids of patients. I've been playing with, or I used to play with, taking those data and making sound from them. That's interesting indeed. They have the rhythm and yeah, that's fun. So you have one there.
Michael, you have also been playing with other types of sounds from the body.
Yeah, pretty much. I mean, of course, again, from a scientific point of view, sound is obviously very useful in make manifest aspect of a certain piece of data or a certain signal that would not be so obvious otherwise. And then artistically, for me, it's an infinite pool of inspiration. So in my pieces, in all these years, I've been using the crackling of bones, heartbeats, blood flowing, sounds of respiration, muscle sounds, of course. And I find fascinating that all these sounds coexist together within our body, and we are not really aware of them. And so maybe coming back to the idea of stillness, I don't think stillness technically can ever exist in our body. And I think the sound from the body are actually a proof of that, as in the same way there is no silence anywhere.
Okay. Other questions from the audience?
Well, I can just
Oh,
add
do you want?
to your question that as a dancer, when I was trained as a ballet dancer, we were taught to not make sound, you know? It should not, no one should hear your feet on the ground, no one should hear your breathing. So it's kind of a reduction of sound, and it was not allowed to make sound as a dancer, which I'm happy that is not valid anymore.
Any other questions out there? Now is the chance to ask questions to a panel of experts on the body and muscles.
I was just wondering if you had any comments on how the brain reacts differently to melody and beat.
Do you want to try that one?
You're the one that does research on beats. So. Well, there are, from the brain perspective, there are different systems in the brain that analyzes rhythm and that analyzes tones. That's one thing. And they merge, of course, and there's a big debate about whether the feeling of rhythm or is a basic physiological concept or not. I don't know. I think it is, but well.
Also, in the new Center of Excellence that we have, we are going to work on the topic of rhythm and human rhythm, and really try to see and understand more about the cognitive foundations for this. So we start out believing that rhythm is a core component of the human cognitive system and kind of also shapes a lot of the things that we do, and has a different also representation than melody, for example, or sequences. So the short answer there is that yes, there is a difference there. Of course, also with rhythm, well, you didn't ask about rhythm per se, but in terms of beat or a steady pulse, one particularly important element there is that when you do have kind of a repetitive pattern or pulse or even a rhythmic structure, that we often find the concept of entrainment, that we kind of get into kind of a synchronized rhythm between, for example, the body and a musical stimulus, or also possibly to have two people that can entrain with each other. So this is a very interesting phenomena that you can find in many different places.
You could do an experiment with that yourself. When the next time you walk beside another person, you will notice that you tend to walk in rhythm. You always tend to walk in rhythm. That's because of this entrainment, that you automatically pick up rhythms or beats within the surrounding environment, and you internalize them. That's interesting.
Another one?
Hello. I'm wondering if it's possible to synthesize a muscle to detail.
People are trying that all the time now, mostly for eating. But I know that they have been making totally artificial muscles from different kind of polymers that actually react to electrical stimulus and that will contract. But they're much slower than our muscles, and they're nowhere near as powerful as our muscles, because our muscles are actually very powerful, even the weakest of us. I know that the last 10 years they've been doing a lot of progress on the artificial muscles made from polymers. But there's a lot of going on the biology side also, that to grow artificial muscles from living cells from scratch. But that's two different sides of one synthesis story, I guess. But it's not very many months ago that I read that they have been making these polymers that react almost as our muscles, only slower and weaker. So I guess it's just a matter of time and money.
One final question from out there.
Yeah, it's a question foremost for the artists, because I wonder if tones somehow they are only fast rhythms, and if you make a tone deeper and deeper and slower, it will at some point change from being a tone to being a beat. And in this gray zone between rhythms that we experience as rhythms or as tones, and to change in between rhythms and tones, has that been exploited by in artists and in these electronic ways? When you record pitches or tones, could you slow them down until they become rhythms? Could that be an expression?
I didn't understand fully. I'm a bit deaf, sorry, so I didn't get fully the question.
Yeah, no. So the question was about the slowing down of, for example, a tone. At some point, it will become more of actually a pulse instead of being perceived as a continuous tone.
Yeah. We've been talking about that during the workshop, actually. I did never try that, but that's actually quite interesting. What I was saying before is that, oh my God, I'm between physiologist and neurologist, but what I was saying before is that for muscle sound, it's really interesting, and most of the energy in the power spectrum sits in the very low end. So between 1 Hertz and 5. And in that range, which are exactly this kind of pulse width signal that we can get, the energy of the sound signal is way higher than anything else that's coming after. Which means, A, we don't know really anything about what's in there, and there's a lot. And second, I don't know, my guts tell me that there is something in that frequency range that also has to do with entrainment and with stillness, which even if counterintuitively, I think they do have a relation. Unfortunately, no, I never tried, but I think it also would be a little complicated to work with that kind of signal in real time, but perhaps with the recordings, it's easier.
I was thinking, where does the tone end and when the rhythm ends? I mean, our ears can, if they're really good, they can detect tones down to about 20 hertz. That's 20 vibrations per second. And below that, our ears can't pick it up anymore. But that is really a matter of power. Because if you have low infrasound that is below 20 hertz, and you go down to 1, 2, 3, 5 in the elephant's hearing range, if the sound is loud enough, or there's enough power in the movement of the air, then you can feel it on your body. And that is really a tone, but your body will pick it up as a rhythm just by the movement of the air. So, and you will not destroy your ears because they're not tuned to that frequency anyway. But your body can pick it up. So people that have been doing research on elephants, they can sometimes feel the air vibrate. And they know the elephants are close, but they can't hear anything, but they're just feeling it, the movement of the clothes on the skin and the body themselves. So I guess that's a crossing point between rhythm and sound or tone.
Cool. I think we'll end the intellectual warm-up here. I would like to thank the panel a lot for coming and sharing all your expertise. And we're going to have a short break now in preparing for the performances. So grab a beer, have fun, and we'll get back to this. And Solveig, want to say a few words as well?
I just really want to thank the panel. You have taught us so much just in the course of less than 45 minutes. And my colleague Lynn just giving you a small attention, just a small gift from us. Then we will have a 10 minutes break. I'm sure all our minds are now properly calibrated to experience the music with both, mind and body. So just grab another beer, go to the toilet, it's just out here, and see you in 10 minutes. Okay, welcome back, everybody. Hope you had a nice break. And now we are turning to the purely artistic part of this show. And first out is a piece by Alexander Jensenius and Karianne Bjerkestrand and Charles Martin, I learned these names today, and Victoria Johnson. And they have performed a similar one. It's not exactly the same, but they have also shown Sverm in the Ultima Festival. So it's really beautiful work. And after that, we transition directly into 2 performances by Marco Donnarumma. And all in all, it will take about half an hour. So I hope you will all lean back and enjoy the show. And if you feel like standing up and moving, that's also perfectly fine. So, okay, welcome. Thank you, Marco. So these last two pieces performed by Marco were called Music for Flesh and Ominous. So thank you so much. And then at the back here we have two researchers. They're called Agatha and Victor, and the guinea pigs already know them. So they have been collecting some muscle information during this concert. So all the guinea pigs who have been wired up for the night, thank you so much. Please go and meet Agatha and Victor again and fill a small questionnaire, and also receive a very little gift from us. Thank you so much. Also want to thank Escape for hosting us, and our amazing technical crew, and everybody for showing up today. That was beautiful. And then we're going to move on to the last section of this, which is data joking. And Alexander will explain a little bit more about this. The first half an hour is going to be streamed, and anybody is welcome to join. Teja Sweeney from Department of Musicology is going to help you get started with the data joking, and it's going to be displayed here on the wall. But for this one, please stand up and mingle and be free. You know, you don't have to sit anymore. So, okay, explain, please.
No, yeah. So the data jockeying, this is really one of the first kind of testing this out. But the idea is really that Teja Sweeney will lead kind of the live analysis of the data that we collected today. And the data will also be available for you to download and play with yourself. But feel free to drink beer, talk, and if you want to, join in with the data jockeying. We'll start it up quite soon. And thanks to Solveig for organizing all of this.